Thank you if you watched my last video. I just wanted to say that I know there's tons of other videos out here already on all the basics of computer science and computer programming, but I just wanted to make sure everybody knows that it's really important to learn this stuff, even if you're just learning about C++ or some other kind of language. And part 1 ended up being a super long video, so I'm probably going to have to make this into a 3-part series. Hey, sorry, I had to change locations to finish the video, so if the mic quality changes, sorry about that. So as I was saying before you take a byte out of coding, you're going to have to take a bit out of coding. So bits or binary digits can only take the state of 0 or 1. What you got to remember is that 8 bits make up 1 byte. A whole huge list of bytes equals the whole entire main memory system. An 8-bit portion of memory is considered 1 byte. So multiple bytes make up the addresses of memory. The memory locations are now called bytes, and these bytes make up what is called the address. More specifically, the number that defines what byte it is the address. So what you can do is you can take a number or letter and store it in one of these bytes. And then the way that the computer knows where to find that information that you stored is they go and they look and they're like, I found an address. Oh, what's in this address? Opens the door, waltzes on in. Oh, look, there's a bunch of data in here. So you might be asking, what happens if things get a little too thick in the trunk? Well, if the data that is stored in a byte is too large, it'll leak into a block of bytes. Once you have a whole block of bytes, the single address used to identify the top of the block of bytes is called the memory location, which is again identified by the very first byte to identify the whole block of bytes that hold the same data. So you can think of the computer's main memory being this whole list of bytes that are divided into different sections, almost like a subdivision of your local neighborhood. And the way you identify each house in a neighborhood is you find somebody's address, right? So the address shows who lives there, what they do, obviously where they live, what kind of house you have. All that information is identified by that person's address. So just imagine when you're working with computers, when the computer finds a certain address, what they're doing is basically driving through a neighborhood, and then they find a house and they see an address and they're like, oh, that's where Kenny lives. So just a little tidbit, if you're kind of wondering why it's 8 bits to make a byte, is because 8 is a power of 2. And if you're working with 2 values, 0 and 1, it's easier to work in powers of 2 than powers of 10. 8 bits just so happens to be the amount you need for 1 letter. To make it easier, we use 8 bits for 1 byte. So you can create 1 letter or multiple letters and numbers. So if you had just main memory, it would take a lot of information and processing power. So there's another thing called secondary memory, which I briefly mentioned. And what secondary memory is basically all these little files that main memory can pull programs from and then take all that data and use it for whatever it's running at that moment. So secondary files kind of store programs and other information, and they're kind of sitting there waiting for the main memory to pull and use. So if we think about the subdivision analogy again, so if you have a whole city, but you only want to find your friend somewhere in that city, you're going to have to know which of those subdivisions he lives in. So in order to visit your friend, you pull the address of that one subdivision, which you can then run your program, which is driving through the subdivision to find the address. Inside of these files, which are the subdivisions around a city, you can store all kinds of things in there, which would be the same kind of data that you would use to store. You would store programs, letters, data entry, anything you want. So the main memory is referred to as the RAM, or random access memory. And it's called the random access memory because it can randomly access any address or memory location that is on your computer. Secondary memory, it kind of works in a sequential variation. So think about the files on your computer. in order to get to the picture you want, you have to go in the picture folder, look in the pictures from 2017, find the picture in 2017 that actually has your picture inside of it. You might also hear what is called the chip, CPU, or processor, and it's essentially the central processing unit brain of your computer that works with the main memory and the secondary memory. What the processor does is it follows the instructions in the program that it is given, and all the CPU can do is follow the instructions given by the programmer, which is you, if you're learning code. The CPU can add, subtract, divide, multiply, all that good stuff, and it can also move memory from location to location. And it's also what is interpreting all the zeros and ones and creating them into letters, which is then sent to an output device, such as your screens.